problem 10.7 show that is x1 plus 1, x plus 1 over n plus 2 is a biased estimator of the binomial parameter theta, and also asked us to figure out whether this estimator is asymptotically unbiased. Okay, so the x is from the binomial distribution, so x is following that, where n is given. We know that expectation of the binomial random variable is n times theta. Okay, so we know that. Now, to figure out to see if this guy is a bias or not, we just take expectation, see if it's equal to theta. Okay, so we take the expectation of this. Remember that only x is random variable, all the other things are constants. So due to the linearity of the expectation, this thing is equal to the expectation of the x, and that's what I have here. And this equals to n theta, as we just said. And then we calculate this guy, and apparently this is not equal to theta. Analyze theta is equal to 1/2. Okay. So apparently this means that this thing is not an unbiased estimator of the theta. Okay, because if it is, it has to be equal to theta for any possible value of theta. But apparently these two things are not the same in general. Okay, so this means that this is not an unbiased estimator, or it is a biased estimator. However, you look at the bias, that means the bias of this guy is equal to the expectation of it minus theta. So we already computed the expectation of this thing, which is already here. Okay, so that's this. We copy it down and subtract the theta, and we see that difference is 1 minus 2 theta over n plus 2. So as you can see, that when your sample size n increases, this thing goes to 0. Right? So that means this, although it is a biased estimator, but it's asymptotically unbiased.